Good morning everybody. Today we are going to see about antenna field zones. Let's have a quick look into the subject. Antenna has three field zones. First one is reactive field zone which has no useful radiation. Second one is radiating near field also known as Fresnel zone. The third one is far field which is also known as Fraunhofer zone. Now let's try to understand the concept with the help of debum or flame. Let's analyze this picture. This is the wax candle. The wax is the feed for combustion. Candle or the lamp wick is the feed element. The flame takes the shape of cubi. The flame has three zones, namely the innermost, the middle and the outermost. The innermost zone is less hot and it's black in color. The middle zone is yellow in color and it is moderately hot. The outermost zone is blue in color and it is the hottest zone. The shape and the color of the flame can be realized using human eyes. The heat can be realized using our touch and can be measured too. So here we have the antenna field zones. There are three field zones and initially it can be classified as near field and the far field. Far field is also known as Fraunhofer and the near field can be further divided into two. First one is the reactive near field, the second one is the radiating near field. It's also known as Fresnel. And the distance, radial distance can be calculated using the formula given here. The shape of the antenna zones are sphere but not visible to human eyes and you cannot feel it. And the radiation range varies depending on the radial distance and the antenna element is fed by a signal from transmission lines or a cable or any waveguide and we can measure it using this radial distance formula. So here we have the dipole antenna and the dipole antenna is surrounded by reactive near field which has no radiation and the region exists is reactive and the radial distance up to which this reactive field exists can be calculated using this formula 0.62 into square root of d cube by lambda meters where r1 is the radial distance from the antenna, d is the dimension of the antenna and lambda is the wavelength of the signal. It is further surrounded by another near field called radiating near field. This field exists if the dimension of the antenna is greater than lambda. The inner boundary is R1 and it is greater than 0.62 into square root of d cube by lambda. And the outer boundary is R2 which is less than 2d square by lambda. So it is further surrounded by another region called Fraunhofer region or far field. The angular field pattern is independent of the distance from the antenna. The field exists for distances greater than R2, that is the radial distance, and it can be measured as 2d square by lambda meters. So the inner boundary is governed by the radial distance R2 that is equal to 2d square by lambda and the outer boundary is infinity. So here you have the summary. Antenna has three field zones. The first one is the reactive near field, no useful radiation provided by it. And second one is the radiating near field, also known as Fresnel. And its radial distance R1 can be calculated as 0.62 into square root of d cube by lambda meters. And then the far field, that is the Fraunhofer, can be calculated using the formula R2 that is greater than 2d square by lambda meters. Thank you.